set up the toolpath. How you go about to machine the thing. So on the left hand side here, just right click toolpath, create toolpath. You guys can see, right?
Yeah.
3D area clearance, model area clearance, click OK. Now this part comes up. Make sure to write your tolerance. You need to change the tolerance, the thickness, these settings.
What's the tolerance? Is how smooth
Tolerance,
it's gonna be,
yeah,
is it? What's an example?
it's
Alright.
This one?
Yeah. So this one has very low tolerance, is it?
basically tolerance everybody shares the same.
Oh, okay.
So we set to a default value. Yeah.
So the default will be 0.01?
Yeah, 0.01.
Okay.
Then next, your thickness. Thickness is how much left over after machining. So this one, we don't want any leftover, so we set to 0.
Okay.
What do you mean by leftover?
When you machine microscopically, there'll be some leftovers. It's not completely, yeah.
Okay.
Yeah, this is amount.
Got it.
And step over means like for example the tool you have. So when you machine, say from step 1 to step 2, how much it overlaps. This is a amount defined by step over. So if you have a smaller step over, meaning that say for example this is the original one circle, then half the circle is being overlapped. Okay, then in that case, compared with the basically the bigger the step over, less overlapping, but then the amount of the burr left behind is more, so it's rougher. But you tend to go faster. So if the smaller the step over, longer the machining time, but your surface condition is better, surface roughness is better. So step over, actually, rule of thumb depends on the size of the end mill. So what size of end mill do you use
So this one is
when you
6.
define for tool?
End of
Yeah.
4.
6, right?
I thought it was 6.
6.
6. So the rule of thumb is half. The step over should be half of the end mill diameter. So meaning here should be 3. Then is your step down. Step down is how much does the tool move down in the Z direction for each step. So basically the higher your step down, the faster you finish. Okay, but too high of a speed, your tool may break. Okay, so for safety purposes, better not go too fast. Okay, so on the safe side, we can set 0.3. These are all in mm. 0.5 still possible, but higher risk of breaking. Okay. Then once you click calculate, the software actually sets out the toolpath. Once you're done, just click cancel. You see this red color icon here?
Yeah.
Click it once, change it to green. Then you can select this mode. Okay, so when you start off, it's just a plain block. Okay, plain block without any of these features now. Okay, then now we're trying to play the simulation that the software has done.
So how do you get from the earlier page? This again, I missed that one. Right after you press the red icon,
once there's a button here. It's just like SolidWorks when you change from wireframe to solid surface.
Okay.
Something like that. Okay, these are all at the top. Then you go to this row. You see this icon here is similar to the one at the bottom. Yeah, it means the same. So there's only one toolpath, and we'll only be dealing with one tool. So we have to specify this. Then here is a typical layer-like button. So
Okay.
speed of simulation is set to maximum. So then you can just click play. So this is a simulation of what will happen during your CNC. So we will mill the slot. So SolidWorks and PowerMill is available at the computer lab, so you can actually do it. Okay. And another extra things you want to know is at the toolpath, you can right click your toolpath and choose statistics. This will show you the total machining time in terms of hours, minutes, seconds. Okay. So basically you're done, but just to let you know, the drawing earlier that you draw for, in this case we use SolidWorks now. This part drawing, yeah, see your middle slot, see the edges sharp, right? But why is it when we come to the simulation it's round? Yeah, that's right. You're using a round end mill, you can never get sharp corners. If you reduce the diameter, you can only reduce the amount of radius, but there'll still be an arc. It won't be sharp corners. Sharp corners is only feasible if you do a milling cut around. Okay? So in your drawing later for your practical, still draw a square slot if there is, and then when it comes up, it's normal if it's rounded. Okay? Okay, then it's alright. So now we've completed the simulation, and then did Olive actually mention to you about saving the file from SolidWorks?
Oh yeah, the IGS.
IGS?
Yeah, make sure you
Yeah.
save in IGS format. But of course, you can save one in the SolidWorks part format just for your reference in case you need to do editing. But when you come for your CNC practical, make sure you bring your IGS file.
Okay.
And this simulation, up to simulation stage, you can do it also in the computer lab just to practice. What you cannot do in the computer lab is actually to transfer this toolpath to the NC code. There's one step before you transfer. Okay. So now we're trying to create the NC code, create NC program. Okay, here name remain. Output file specify what is your NC program title. So I think you're group 3, right?
Yeah.
Yeah, so this example, group 3. So when you save, it'll be a file called .tap. You guys, if you can't see, just come closer. Okay. So click save. Now the machine option file. This is a special file that we need to select. So once you click the icon to browse, immediately you come into this folder called Darkpost. But what you want is the file located on the desktop called fanucom.opt.
Okay.
It's different from what in the worksheet. Your worksheet, I think, refer to page, the lab sheet, page 15, Fanuc. But the file is fanucom, not Fanuc. So from here, go back to desktop. The file name is F. So yeah, see, fanucom.opt.
Okay.
Click open. Basically, yeah, you're done here. Just click apply, click accept. Then under toolpath here, you need to, you know how to get to here, right?
Yeah.
Each time you create something, there will be a subfolder. So go to number 1, right click, add to NC program. Then under NC program, look for 1, click right. So now it's transferring your toolpath into your NC program. So once you're done here, you're done with the NC program, but you need to make some modifications. So when you specify your output file, always remember where you save it. Okay, so remember, see, group 3 dot tab, just double click. This software not available in the computer lab, so can only be done here. So this is a part where practical you have to do it. So this is your NC program. Looks familiar, huh?
Yeah.
Your N, your M codes and your G codes. So here there are certain rules that you need to make modification before you send it over. First item is look at the colon. Colon needs to be changed into capital O.
Sorry, what's that again?
Colon
Oh,
change into capital O.
alright.
So these 4 digits at the back, capital O not 0. The 4 digits at the back is your program number. So you need to remember your program number. Make sure, because when you send it over there, you need to call it exact program number. So you group 3, I set it 3. Okay. So if someone already used a number there, don't use the number.
Okay.
Yeah. When you press list program there, you can see a list of programs already in the memory. If you want to use the same program number, you got to delete before you send over.
Oh.
Next item, M13. This is one of the M codes. M13 needs to be changed to M03. This is always at line 6, N6. M13 changed to 03. This is because M13, I'm not sure the actual cause, there could be 2. One is actually, this is a 3-axis. M13 refers to 5-axis brake, so doesn't apply. For the second one, this M13 is actually asking it to spin clockwise with coolant on, but we already set the coolant on already, so we just want it to spin.
So what happens if you don't change the M13? I mean, does it have any effects?
Yeah, I think when you run it, either it won't run or the coolant will have some issue. These are just unique to this, maybe to this model and the software. Okay. The next item that you need to change is actually the feed rate. So use this icon, the one with the binoculars and the B. Click this. This is the same like find and replace. So do this for F500. Basically change F500 to F500 with a dot.
Oh.
Yeah. Do that and replace all. Then do the same for F1000. 1000 with a dot.
Why do we need to replace that? I mean, isn't that is it the same thing like the feed rate?
So even for 3000 as well.
3000.
3000 as well. There's a dot behind.
There's a
This
dot
is
behind.
programming.
Was it 500,000 and 3000?
No, 500,
500.
1K, 3K.
Okay.
But when you do for 3K, in this case, it doesn't have so much detail. This actually depends on your part design,
Okay.
the NC program. Yeah, NC
So
program.
every time, every program, we need to change
Yup,
the
do
5
this.
and the 1000.
So what
Yeah.
is the feed rate?
Feed rate is actually the speed of your members,
The axis moving, is it?
the XY
Okay.
that actually holds your sample.
Okay.
Yeah, feed rate is. Remember in the class I said mm per minute. Yeah. Okay, so there isn't, so just close and then just click save. Then the button to send the code over to the CNC machining is this one, send code. But we don't do it yet because remember we have to set up this.
Yeah.
So you, Mr. Alif has shown you how to.
Not mine. You
No,
went
no,
straight
no.
to programming.
Yeah.
We only.
You didn't open the tool holder.
We opened the tool
Yeah.
holder.
Mounting it? No.
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 Oh, okay.
Basically, open the tool holder and came straight.